Hey everybody, Merry Christmas. Wow. All right, I want to go over the problems from the review that you all have looked at already. And the first question says, if a figure is a rhombus, then it has four congruent sides, and what you need to do is identify the hypothesis and the conclusion. The hypothesis is the statement directly following the if, and the conclusion is the statement directly following the then. The hypothesis does not include the if, the conclusion does not include the then, so the hypothesis is a figure is a rhombus, and the conclusion is it has four congruent sides. Write each as a conditional statement. Number 2 says two supplementary angles have a sum of 180 degrees. So you take the first part, put it after the if, the second part after the then. If two angles are supplementary, then they have a sum of 180 degrees. And you might need to tweak the wording just a little bit. You need to get the thought that's there. You can't add in any new thoughts. You just have to tweak the wording so that you keep the same thought, but you write it as a conditional statement. Number 3 says, determine whether the conjecture is true or false. Give a counterexample for any false conjecture. It says, given two odd numbers, conjecture the sum of the two odd numbers will be even. There is no example that I can think of, no counterexample, that refutes that as a true statement. In other words, there's nothing that is an example where two odd numbers are added together and they're not even. So the truth value of that is that statement, that conjecture is true. Justify each statement with a property of equality, a property of congruence, or a postulate. If x plus y equals z and y equals 2, then x plus 2 equals z. What happened is the 2 replaced the y in the first part of it where it says if x plus y equals z. We substituted the 2 in for the y, and then we have x plus 2 equals z. That's the substitution property of equality. For number 5, it says angle ABC is congruent to angle ABC. That is the reflexive property, not the symmetric. The reflexive property is something is congruent to that exact same thing. So that's the reflexive property of congruence. The symmetric property, you take the left side. If the left side equals the right side, then the right side equals the left side. If CD equals LK, then LK equals CD. That's the symmetric property of equality. If angle if angle C is congruent to angle D and angle D is congruent to angle E, then angle C is congruent to angle E. That's the transitive property of congruence, because if you have anything that says if the first thing is congruent to the second thing, and the second thing is congruent to the third thing, then the first thing is congruent to the third thing. Next it says if point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. That is the angle addition postulate. All right, moving on to number 9. It says define a linear pair. A linear pair are any two angles that are supplementary and adjacent. They add up to 180 degrees and they share a common side. Draw a diagram. Well, here's our straight angle, and we have a ray coming off that straight angle. Angle 1 and angle 2 are a linear pair. They're supplementary and they are adjacent. We need to use the diagram below to answer question 10 through 12. Number 10 says fill in the blank. Angle 3 is congruent to angle 6. Well, if angle 3 is congruent to angle 6, that means that they're alternate interior angles, and if they're congruent, that means that the two lines that are crossed by the transversal have to be parallel. So in this case, A is parallel to B. Line A is parallel to line B. Sorry about that. Then we have if the measure of angle 1 equals 56 degrees, find the measure of angle 3 and the measure of angle 6. Well, if the measure of angle 1 is 56 degrees, 1 and 3 form a linear pair. That means 3 has to be angle 1 supplement. So what we can do is we can take 180 degrees, subtract 56 degrees, and that means that the measure of angle 3 has to be 124 degrees. And if angle 3 is 124 degrees and angle 6 is the alternate interior angle with angle 3, and those lines are parallel, then angle 3 and angle 6 have to be congruent. Therefore, the measure of angle 6 also has to be 124 degrees. If it says if the measure of angle 4 is 124 degrees, which if you look at angle 4, it's obviously not 124 degrees if the drawing is to scale. So let's just assume that the drawing is not to scale. Find the measure of angle 5 and the measure of angle 8. Well, if the measure of angle 4 is 124 degrees and angle 5 and angle 4 are alternate interior angles, then the measure of angle 5 has to be congruent to the measure of angle 4. Therefore, that would be an 124 degree angle also. Angle 5 and angle 8 are vertical angles. Those also have to be congruent. So angle 8 as well as angle 5, along with angle 4, the measure of those angles are all 124 degrees. Moving on to number 13, it says complete the two-column proof for questions 13 through 17. It says given FE is congruent to 2x plus 20 and equals FE equals 2x plus 20 and ED equals 2x plus 18 and FD equals 10. Using the diagram, we need to prove that x equals negative 7. So once we get to x equals negative 7, we've written all the statements that we have. Then we just need to make sure that we have corresponding reasons for those. So I'm going to write the given statements that are here. Hold on, Rowan. Oh, thank you very much. Can you say hi to everyone? Come here. Say hi.
Hi.
Say bye-bye.
Bye-bye.
Okay. So I wrote down the given statements, and I'm not going to repeat them all because they're right there. You can see them. Then what I did next, I used the segment addition postulate to show that FE plus ED equals FD. Segment addition postulate. This segment plus this segment equals this larger segment. Then I used substitution to say, instead of writing FE, I wrote 2x plus 20. Instead of writing ED, I wrote 2x plus 18. And instead of writing FD, I wrote 10. Now, I'm going to combine in the next step the 2x plus the 2x, and I'm going to make that equal to 4x. I'm going to combine the 20 and the 18. I'm going to set that equal to 38. Now, I did not add anything to both sides of the equal sign. Therefore, it is not the addition property of equality. All I did was simplified the left side of the equation, so I'm going to use as a reason simplify. Now I'm going to subtract going from step 4 to step 5. I'm going to subtract 38 from both sides. Now it is a property of equality, and since I use subtraction, it's the subtraction property of equality. In step 5, I have 4x equals negative 28. Now I'm going to divide both sides by 7. I'm going to divide both sides by 4, and I'm going to get that x equals negative 7. Since that is what I'm trying to prove, I don't need to write any more statements, and I'll just finish this up by writing the reason for that statement. Since I divided both sides by 4, it's the division property of equality. Moving on to number 14. It says, given the measure of angle JKA equals x plus 36, and the measure of angle AKL equals x plus 75, and the measure of angle JKL equals 91, prove x equals negative 10. I'm going to do something very similar to the prior proof, except instead of the segment addition postulate, I'm going to use the angle addition postulate. So I'm going to write the given information, and then what I'm going to do is I'm going to set up an equation where I have the measure of angle JKA plus the measure of angle AKL equals the measure of angle JKL. And that is the angle addition postulate. I'm then going to substitute in what I know about angle JKA. So instead of writing the measure of angle JKA, I'm going to write x plus 36. Instead of writing the measure of angle AKL, I'm going to write x plus 75. And instead of writing the measure of angle JKL, I'm going to write 91. Since I'm replacing those values with something it's equal to, I'm going to use the substitution property of equality. Then, just like in the last proof, I'm going to combine x plus x on the left side and get 2x, not the addition property of equality. I'm going to combine 36 and 75 on the left side, not the addition property of equality, because I'm not adding something to both sides. I'm simplifying the left side of the expression, so I have 2x plus 11 equals 91. Then I'm going to subtract 111 from both sides and get 2x equals negative 20, which is the subtraction property of equality. I'm then going to divide both sides by 2, get x equals negative 10, which is what I'm trying to prove, so I don't need to go any further. And I'll justify that with the reason of division property of equality. Moving on to number 13. Number 13 says, oh, I think I did 13 already. Hold on. I just did 13. Sorry about that, I went in the wrong direction. Number 15 says, given line L is parallel to line M and line P is parallel to line Q, prove angle 1 is congruent to angle 2. I wrote down the given information, and then what I did is I looked at this and I said, well, if line L is parallel to line M and P is a transversal, 1 and 3 are alternate interior angles that have to be congruent. So I put angle 1 is congruent to angle 3 because of alternate interior angles. Then I said, using the same reasoning, angle 3 is congruent to angle 2 because of alternate interior angles, since I know that P and Q, those lines are parallel, M is a transversal, 3 and 2 have to be congruent. I then used the transitive property of congruence, showing that if angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then angle 1 has to be congruent to angle 2. Since that's what we're trying to prove, we're done. We've got 2 more to go. We have given angle FED and angle DEW are complementary angles. Angle FED and angle DEW here are complementary. They're complementary angles. That's given, I wrote it down. And then what I did was, if they're complementary, I said that the measure of angle FED plus the measure of angle DEW has to equal 90 degrees. Why? That's the definition of complementary angles. That's why. After that, I substituted, instead of 90 degrees, I substituted in the measure of angle FEW. Because, I'm sorry, I didn't do that. What I did was I said the measure of angle FED plus the measure of angle DEW equals the measure of angle FEW. I used the angle addition postulate there. Now is when I substituted. Since I know that the measure of angle FED plus the measure of angle DEW equals 90 degrees, instead of writing measure of angle FED plus the measure of angle DEW in step 3, I made that 90 degrees in step 4. I set that equal to the measure of angle FEW by the substitution property. Now, since the measure of angle FEW equals 90 degrees, I know that FEW has to be a right angle by the definition of right angles, because that's what constitutes a right angle if it's 90 degrees. Moving on to the last one. I crossed out step 3. You might have done this a different way, but this is the way that I did it. It says KM bisects angle JKL. That means angle right here. If KM bisects JKL, and that's given, I know that angle 2 is congruent to angle 1 by definition of an angle bisector. I also know angle 1 and angle 3 are vertical angles by the definition of vertical angles. Right here, angle 1 and angle 3 are vertical angles. Then, since I know that angle 1 and angle 3 are vertical angles, I can write that angle 1 is congruent to angle 3. Why? Because vertical angles are congruent. Now, you'll notice in step 2 that I didn't write angle 1 is congruent to angle 2, because if I'm going to use the transitive property, which I foresaw that I'm going to use, I said if angle 2 is congruent to angle 1 and angle 1 is congruent to angle 3, then by the transitive property of congruence, angle 2 has to be congruent to angle 3, and so I wrote that down. And that's that. We're done. We're DUN done. If you have any questions, email me. Let me know. I'll talk to you soon. Math it up.